Hello everyone, welcome to our next video lecture. Today I am going to discuss about factors affecting rate of corrosion. Corrosion is a natural phenomenon where the metals exhibits revert back in tendency to their native combined states. Due to corrosion, metals will exhibit deterioration and destruction. Corrosion is a potential or it is a challenging thing in the industries. Since it is a natural phenomenon, we cannot stop it, but we can have a control on the corrosion. If we would able to know what are the factors influencing rate of corrosion, we can get an idea how to control the corrosion. Hence, today we are going to discuss about factors affecting rate of corrosion. Various factors can influence the rate of corrosion, which can be broadly categorized into two parts. So, first one is the nature of metal. Broadly, the nature of metal can influence the rate of corrosion. Similarly, nature of environment can influence the rate of corrosion. Nature of metal in turn depends upon so many other characteristics of the metal, which we will be elaborately learning during this lecture. So first we'll have a look on the factor nature of metal, how various characteristics of metal can influence the rate of corrosion. So if we come to the nature of metal, how it is influencing the rate of corrosion, the first factor would be position of the metal in the galvanic series or electrochemical series. So if we see the galvanic series, the series we get on arranging all metals and alloys in the increasing order of their corrosion resistance. That means their corrosion tendencies would get decreased from top to bottom. That means the metals which are above the galvanic series are having high tendency to get corrode because they are having high oxidation potential. The metals which are having the high oxidation potentials always having the tendency to lose electrons and get corrode fastly. That is why the metals which are placed above in the galvanic series are generally having the tendency to get corrode. So in the galvanic series, zinc, magnesium, cadmium, and their alloys are placed above the galvanic series. They are having the high tendency to get corrode. Then if we come to the second one, relative anodic and cathodic areas. If we see a metal, the metal, uh, some of the part of the metal can become anode and some of the part of metal can become cathode due to the uneven exposure of the metal to different aerated conditions. We already discussed high aerated part will become anode, less aerated part will, sorry, high aerated part will become cathode and less aerated part will become anode. So here, if there is a formation of anodic and cathodic regions, if there is a presence of large size cathodic area, which is in contact with small anodic area, the rate of corrosion would be greater because large cathodic area require more electrons to get satisfy the corrosion current. So anodic part continuously must supply electrons to the cathodic regions. Hence, continuous corrosion can be observed if large cathodic areas are in contact with small anodic areas. That means, how do we can control the corrosion? If we could able to maintain small cathodic regions which are in contact with large anodic areas, we can somewhat control the corrosion part. Similarly, the nature of metal, which in turn depends upon purity of metal. High is the purity of the metal, high is the corrosion resistance. That means the tendency of corrosion would be less. I mean, to not undergo into corrosion, high purity levels of the metal have to be maintained. Then If we come to the other factor, physical state of metal. So, like whether the metal grain size is less or high, whether the metal is having stressed areas or less stressed areas. So, if we come to this grain size, less grain size will provide more surface area to get exposed to the environment. Hence, the rate of corrosion would be greater. That means the rate of corrosion would be greater if the grain size is small. Similarly, if a metal is having stressed portions, the stressed portions will accelerate the rate of corrosion. Then the other part is the nature of corrosion products. If we come to the nature of corrosion products, like the best example is rust. The form of rust is it is nothing but the oxide layer of iron that of the Fe2O3 XH2O layer. That is the corrosion product is porous in nature. Since that is porous in nature, continuous penetration of oxygen can be there onto the metal, which will lead to the continuous accelerated corrosion. Similarly, in case of magnesium also, that possesses porous oxide film. In contrast, if you see aluminum, chromium, nickel, they are also exhibiting metal oxide films, but the former metal oxide films are highly protective because they are stable metal oxide films. So then, and as in other way also we can explain passivity characteristic. Aluminum, chromium, nickel, tungsten, these are exhibiting uh, passive characteristics, passivity characteristic, where highly protective, very thin, self-healing metal oxide film can be formed on the metal surface. Due to that, it the metals are exhibiting high corrosion resistance, passive metals, aluminum, chromium, nickel, tungsten. So we come to the other factor, solubility of corrosion product. So corrosion product solubility. If the former corrosion product like rust is readily getting soluble in the environment. So again and again, the metal will expose to the environment and lead to the corrosion. Then if we come to the other factor, that is volatility of corrosion products. So corrosion, if the formed corrosion products are volatile in nature, the rate of corrosion will be greater because again and again metal surface is exposing. Volatility means readily evaporate. So corrosion product is readily getting evaporated. Corrosion product is readily getting evaporated. Again and again the metal surface will exposed to the environment. So there will be again and again corrosion take place. Then so far we have these are the factors which are influencing the rate of corrosion under nature of metal. Then if we come to the nature of environment, so many environmental factors can influence the rate of corrosion, but few of them we are listed over here. Temperature, number one. So if we see any mechanism in the high temperature cases, the rate of chemical mechanism would be greater. Similarly, the corrosion mechanism can enhance as the temperatures are enhanced. So that's why the tendency of corrosion also greater. Similarly, humidity. High is the humid conditions. High is the rate of corrosion because humidity will enhance the greater electrochemical corrosion cell formation. So that's why the rate of corrosion would be greater. Then if we come to the other part, that is effect of pH. So in generally all metals in presence of acidic environment, they participate in corrosion. Whereas in the alkaline and neutral environment, the rate of corrosions are less. Then if we come to the formation of oxygen concentration, if there is a difference in oxygen concentrations that is leading to anodic and cathodic regions, there will be the high rate of corrosion at the anodic part. You all know that highly aerated part will become cathode, less aerated part will become anode. Then if we come to the other part, nature of ions present. So if there is a presence of stable, insoluble ions like silicate ions in the environment, those will interrupt and inhibit the rate of corrosion. In a similarly, if there is a presence of chloride ions which are having ready reactive nature, there will be the high rate of corrosion. That means this concept can helpful in the invention of corrosion inhibitors. Presence of the other factor is presence of suspended particulates compounds, suspended particulate compounds like NaCl, ammonium sulfate, and moisture conditions. If present in the environment, the rate of corrosion would be greater. Then other factor is conductance of corroding medium. In the case of underground and submerged structures, the conductance of the medium influence the rate of corrosion. Conductance of dry sandy soil is lower conduction. So the rate of corrosion will be less. But whereas whereas in the liquid medium, the rate of conduction would be greater. So hence high corrosion tendencies we could see. So these are the different factors can influence the rate of corrosion. So if we come to the conclusion, so far we have discussed about what are the factors influencing rate of corrosion. Broadly, we have classified them into two types, nature of metal and nature of environment. Nature of metal in turn depends upon different factors. What are those? Position, purity, then relative anodic and cathodic areas, and their conducting characteristics, their volatility nature, all those. Then in a similar manner, under the nature of environment, we have discussed about how the temperature is influencing the rate of corrosion, pH, humidity, uh, then presence of like impurities in the environment, how they are enhancing the rate of corrosion. So with all this knowledge of factors influencing corrosion, we can think about the corrosion control process. With this, I am stopping my lecture. Thank you all.